Hi, this video is about the two main categories of waves in physics. In a previous video, I've talked about how to be a wave. To be a wave, you need to follow these two rules. One, you're not allowed to carry any matter with you, only the energy that's present in the original disturbance that created you. So if you want to be a wave, I'm sorry, you can't carry any matter with you. Rule number two is that you need some kind of medium to travel through. Almost all types of waves need something that they can pass through or travel through, and we call that the medium. So let's look at some examples of waves to help us understand these two rules. And in these examples, we'll uncover two main categories of waves. So let's look at first an ocean wave. Now, I want to also talk about the two different rules for the waves as well, so you can see these two rules of how to be a wave and see how they kind of work out. So, an ocean wave. Does an ocean wave carry matter with it? Surprisingly, no, it does not. And that's because the wave just passes through the water, and the water particles move, but they really just go in circles over and over as the wave kind of washes over them. But the water itself doesn't get picked up and moved across the ocean. Okay, what's the medium for an ocean wave? And we've already alluded to this, but if you drop something in the water, you create a disturbance. What is that disturbance traveling through as it goes to the end of the, to the beach or to the shore? It's traveling through water. And so the medium for an ocean wave is water. All right, excuse my bad handwriting. I'm kind of writing at a weird angle here, but let's talk about a sound wave. So a speaker produces a sound wave. Does a sound wave carry matter with it? No, it does not. What is the medium for a sound wave? If it's traveling on Earth, the medium is going to be air. If we're talking about a speaker producing a sound wave, it goes from the speaker to your ears. In between you and the speaker, there's air. If you took all the air away, then there would actually be no way for that sound wave to travel, and it wouldn't travel. There would be no wave anymore. And that's why there is no sound in space, because there's no air for sound waves to travel through. Now, sound can also travel through, liquids and solids as well. So it can travel underwater, it can travel through the ground. Actually, that's what an earthquake is. An earthquake is just sort of like a sound wave, a really strong sound wave traveling through the ground. It's vibrations in the ground. Do earthquakes carry matter with them? Now think about this. They definitely shake up matter, right? The ground is being shaken up. Your house might be shaken up by an earthquake. But does your house get picked up and moved to another city in an earthquake? No, it doesn't carry the matter with it. So the earthquake wave, the shock wave, goes through the earth, but it doesn't pick up the earth and carry it with it. So that's what we're focusing on here. It doesn't carry matter with it. The medium is, of course, the ground. That's what the wave is passing through. Now, what about a slinky? Okay, a slinky, you can make fun waves with a slinky. As you shake a slinky up and down, do the parts of the slinky at your hand get picked up and travel across the other end of the slinky? No, it doesn't carry matter with it. And the medium for a slinky wave would just be the coils of the slinky. So if you think about a slinky as a big spring that's been coiled up, it's just the coils that carry that wave. Now this one's kind of weird. I think of this sometimes as like a wave. If you have a walking stick and you hit it up against the ground, when that walking stick makes contact with the ground, I can use this. It makes contact with the ground, the ground is actually creating a little shock wave that travels up through your walking stick to your hand to let you know that you've actually hit something solid. It's very quick though, so it's a very fast wave, but it's like a little sound wave that travels through your walking stick. Does that carry matter with it? Does the little piece of the walking stick at the bottom get picked up and carried? No. You should see a pattern at this point. No, it doesn't carry matter with it. And the medium for this would be just the stick itself. That's what the wave passes through. All right, what about light waves from the sun? So the sun is, always giving off light waves in every direction. Does that mean pieces of the sun are actually getting picked up and carried to us? Not in a light wave. There are kinds of pieces like that called solar wind, but that's not the same thing as a light wave. So light waves do not carry matter with them. What's the medium for a light wave? Through space, What's in between us and the sun? Well, this is where we have something different happen, because there's nothing between us and the sun. It's empty space. And because of that, light waves do not need a medium to travel through. This is the one exception to the rule. Light waves are the only kind of wave that we know of that doesn't actually require a medium. It can just keep itself going. Another name for a light is electromagnetic radiation. And if you've learned about electromagnetic induction, you know that an electric field that moves up and down can generate a magnetic field. And a moving magnetic field can generate an electric field. And so a light wave is really just electric and magnetic fields that just propel itself. It keeps itself going, and it can travel through empty space. It doesn't need a medium. Light can travel through some media like, glass or air or water. It can travel through them, but it doesn't need a medium. So one more example, heat from a fire. If you are standing next to a campfire, you can sometimes feel the heat from it on your leg. So there's some kind of heat being passed from the fire to you. Even if you put the fire out, you can still kind of feel some heat from the ashes at times. So there's some kind of heat wave that's passing through there. Does it carry matter with it? No, we know that that's not how waves work. But what medium is that passing through? Sometimes it is the air, but actually heat is a type of light. And so it doesn't actually need a medium to travel through. And that should make sense because the sun also gives us heat. And so heat is another type of this light wave. So we have two different kinds of waves, two categories here. We have these two at the bottom that are light waves, or as I've said before, I said earlier, they're called electromagnetic waves. And this is one category of waves that basically they don't need a medium to travel through. They carry themselves through outer space because they are electromagnetic waves. These other ones that need some mechanism or some medium to travel through, they need something that can carry them, they're called mechanical waves. And mechanical waves, like I said, they need a mechanism, or they need something that carries them in order to actually exist. So these are the two different categories for waves. So if we went back to our original two rules for how to be a wave, we could amend this. Instead of saying almost all types of waves need something to travel through, we could say, instead of almost all types of, we could say mechanical waves need a medium to travel through. So if you're going to be a mechanical wave, you must find some medium to pass through. Electromagnetic waves do not need a medium. So those are the two categories of waves. And that's all I've got for you in this video. Remember, humility is not thinking less of yourself, it's thinking of yourself less.